Hello guys, today I and my friend Apramey will be discussing about object detection by image processing by using deep learning and Caffe. There are many ways of image classification like Haar cascade, machine learning and deep learning. But the problem with image processing with Haar cascade and machine learning is we need to specify the feature set, and as humans we may skip some important features and which may lead to wrong classification of the image. But in deep learning, both feature extraction and classification is done by neural net, and as you can see in the image, as neural net contains neurons as basic building block, we will be studying about them. This is a typical neural cell of human brain. Dendrites receive the signal from the other neurons. Cell body sums up all incoming signals to generate input. When sum reaches a threshold value, neuron fires and signal travels down axon to other neurons. The amount of signal transmitted depends on the strength of the connections. So researchers made an exact replica of neuron and formed a neural net. So you can see in the image there are inputs x1, x2, x3, so on up to xn, with weights associated with them w1, w2, w3 and so on. The weights specify the strength of the interconnection between neurons inside the neural net. The summer sums up the product of weights and input with the bias. If greater than threshold, it gives the output. So in this image we can see the interconnection. There is input, there is hidden layer and their output. And each node is connected to each other node, and in first cycle we may get the wrong output, but to the input we backtrack and then send the interconnections to the input, and this cycle goes on till we get the required output, and this becomes our pattern. So this is how a deep neural network works. So there are different popular neural network architecture: single layer perceptron, radical basis network, multi-layer perceptron, recurrent neural network, LSTM recurrent neural network, hopified neural network, Boltzmann machine. So this sums up about the neural network, and the Caffe model will be conveyed by my friend Apramey. Thank you.
Hello everyone, I am Apramey. Thank you Kiran for briefing about deep learning and neural networks. For our object detection module in our project, we are using Caffe. Present slide briefs you about what exactly Caffe is. It's a deep learning framework, or else we can say a library. It's made with expression, speed and modularity in mind. Developed by Berkeley Artificial Intelligence Research and created by Yangqing Jia. There are many deep learning or machine learning frameworks for computer vision like TensorFlow, Theano, Keras and SVM. But why exactly we implemented it on Caffe? Reason is its expressive architecture. We can easily switch between CPU and GPU while training on GPU machine. Modules and optimization for our problem is defined by configuration without hard coding. And it supports extensible code. Since Caffe is an open source library, it is forked by over 20,000 developers in GitHub since its birth. It offers coding platform in extensible languages like Python and C++. And the next reason is speed. For training the neural networks, speed is the primary constraint. Caffe can process over 60 million images in a single day with a standard NVIDIA GPU. That is 5 milliseconds per image. Whereas the same dataset of 60 million images can take weeks for Theano and Keras. Caffe is the fastest convolutional neural network present. Community. As mentioned earlier, since it's an open source library, huge number of research are powered by Caffe, and every single day something new is coming out of it. This graph depicts the decrease in the error rate after Caffe is introduced. From 28.2 error rate to 3.57. That's a commendable achievement. The deepest Caffe neural network fosters about 152 layers. In computer vision, detection and classification are two different aspects. Detection is the task of recognizing not only what is in the frame, but where, both identity and location. But classification considers only mere presence or absence of an object. There are many challenges for both aspects. Localization. As we can see, both person and horse pixels are overlapped on each other. Multiple instances and small objects. We can see small cars in the given example. How exactly we implemented Caffe in our project? As mentioned earlier by Kiran about different neural networks, we are particularly using CNN, that is convolutional neural network. And for that convolutional neural network, we are implementing ReLU, that is rectified linear unit. What exactly is ReLU is again a huge discussion. To tell in brief, we know that deep learning is all about layers, and to move from one layer to another layer, we need a transformation function for that. And that function basically implements matrix multiplication or min-max theory or non-linearity check between the nodes of the same layer. ReLU is the one framework which employs everything under a single algorithm. And the visual structure of our Caffe model involves local processing like resizing and contrasting of image. Next step is convolution or filtering, that is implementation of ReLU. Then pooling, that is the part where our neural network learns about the input image, and lastly the output. This is the outcome after implementation of our Caffe model. This is the standard 3-staged neural network. Whenever an input image is put for questioning before the neural network, it compares with all the layers, and lastly fully connected output scores our input as car. Now coming to our IoT project. Our Caffe model brews something like this. Presently the neural network is trained for person and bottles, so it is going to detect person and bottles in real time. Thank you. Useful links are in description. Please check it out.